We're going to start factoring polynomials, and of course, as you have learned in previous math classes, you should always look for what we call the greatest common factor, or we should refer to it possibly as the GCF. What is that GCF? The first thing we look for is it the largest number that will divide into all the terms. And so as we look at number 1, 14, 21, 28, you should be thinking, well, they're all divisible by 7, and you're correct. However, we also want to look at all the variables that occur in all the terms. So again, we have x's in all of these, but then we look at the powers. We have an x cubed, x squared, x to the fourth. And so the GCF for the variables would be the one that's raised to the smallest power. That's how many they have in common. They would all have x squared, or x times x, in common. So let's look at this first problem. It says just find the GCF. So once again, we look at the coefficients and ask ourselves what is the highest number that divides all of these, and of course it is 7. Then we look at the variables, and they all have an x, and we look at the lowest power, and so we would have an x squared, and that's the GCF of number 1. Let's look at the second one. Again, we look at all those coefficients and ask ourselves what's the largest number, if any, can divide 16, 24, and 8. Well, they're all divisible by 8. Now, let's look at the letters. Well, this one has an A, but this one doesn't. So automatically A is not in common because they don't all have it. And then again, this one has a B, but the other ones don't have it. And so B is not common to all of. The only GCF we would have is 8. However, we could also say that negative 8 is a common factor. Just like over here, we could have said negative 7x squared. Sometimes when the leading coefficient is negative, having a negative GCF will help our further factoring. Now that's not factoring, we have just located what is the greatest common factor. Most of your homework is going to say, factor the following, meaning that's really division. Where did we get this trinomial? What did we multiply together to get that? So again, we're looking for a greatest common factor. So we look at the coefficients, 8, 18, and 2. Since they're all even, they're all divisible by 2. So we want to write down 2. Then we want to look at the letters. That has an x, that has an x, that has an x. And the highest power is just to the first power, so 2x. That's the GCF. But what do I multiply 2x times to get back the original problem? Well, one way is to divide each of these by the common factor of 2x, because remember, factoring is really dividing. So if I divide 8x squared by 2x, 8 divided by 2 is 4. X squared divided by x is x. Then we would have plus 18 divided by 2 is 9. And then basically the x's cancel out or divide. X divided by x is 1. And then we would be left with the 9. And then here's the most common mistake, is a lot of students think, oh, well that just cancels out and I'm done. No, divide. 2x divided by 2x goes in there one time. That would be your answer. So one way to check, although not 100%, is to multiply your answer out, and you should get back where you started from. So if you started out with a trinomial, you're going to end up with a trinomial if you have factored out a greatest common factor. So let's look at this next example. So we want to look at those coefficients, 7, 35, 14. But also notice that they're all negative. So I think I'm going to take my GCF out as a negative 7. I see a lot of letters. That has an x, that has an x, that has an x. And so x must be part of it. But let's look at those powers. X to the fourth, x squared, x squared. So x squared is the lowest. Do they all have a y? Yes, they do. And the lowest power would be y to the first power. So that's the GCF. Now we should divide each one of these by that GCF. And if you can do that in your head, that's great, but I'm going to write it down so we can actually see that division. All right, so here the negative 7s would divide out, But x to the fourth divided by x squared would leave you an x squared. And then the y's would also divide out. Let's look at the next term. We have a negative divided by a negative, and so that's going to be positive. 35 divided by 7 is 5. The x's would divide out, as in x squared divided by x squared is 1. And then when the y's divide, y squared divided by y would give you y. On the third term, again, a negative divided by a negative is positive. 7 goes into 14 2 times. X squared divided by x squared is 1. And then when we divide out the y's, again, remember, you would just subtract the exponents and you would have y to the fourth power. So GCF, you want to look at the numbers and the letters, and sometimes a negative is helpful. Now, just to say, if you did not take out a negative 7x squared y and you took out a positive, what would happen is you would have the same thing except the signs would change. So this is also an acceptable answer, but I think this one is a little bit prettier. Now you notice on these next two examples, they don't quite look like what we just did. They're not just trinomials or polynomials. They look like we have, a group of terms separated and then another group of terms. Well, this is a different type of GCF. Instead of a monomial, a single term, sometimes a GCF could be a binomial. For example, you should notice that 3x plus 9 and 3x plus 9, they have that in common. So let's see, what if I said, let's take out that 3x plus 9. Let's divide each term by 3x plus 9 and see what happens. Well, again, 3x plus 9 divided by 3x plus 9 is 1, and so that would leave me 7y. Here, same thing, and I would be left with minus 14z. Is that factored all the way? Well, it's factored some. Certainly if I were to multiply that out, I would get where I started, but I see some other things. Perhaps I didn't take out the greatest common factor. Maybe I just took out a common factor of 3x plus 9. Let's see, is there more stuff, more common factors to take out? Let's look here. 3x and 9. What are those both divisible by? I believe they're both divisible by 3. So if I take out a 3 and divide each of these by 3, I'd leave x plus 3. Now look, what about these? What are those both divisible by? Hopefully you're saying, oh, well, duh, 7. All right, so if I take out a 7 and I divide both of these by 7, I'm left with y minus 2z. Well, that's an okay answer, but it certainly is ugly. Usually we don't see this 3 and 7 separated. So let's go ahead and multiply that together and make that 21. And let's just write down the other factors. So that's one way to work that problem. Could we work that another way? Let's see if we can work number 5 by not just taking out the 3x plus 9, which is obviously in common. Let's see if we can take out the whole greatest common factor. Right. So let's start. Well, if you look at the coefficients, the 7 and the 14, you should say, all right, they have a 7 in common. The y and the z are not in common, but we also know that 3x plus 9 is in common. So what if I divided each term by that common factor? Let's see what we would get here. All right, so again, we would reduce. And what's the only thing left is a y. And here we would reduce. 7 goes into 14 2 times. Don't miss that minus sign, so we'd have a minus 2z. Now, is that the same answer we got just a minute ago? No, because of this. This is kind of tricky. That still has that 3 in common, so I'm going to leave that 7 times 3. Divide each of these by 3. And again, I'm going to put those two together. And we end up with the same answer. So it's kind of like you either pay me now or pay me later, but you've got to find all the common factors and make it the greatest common factor. All right, let's look at number 6. If we look at those coefficients, 15 and 5, yes, those are both divisible by 5. And so that's probably going to be a common factor. But let's look at those parentheses, y minus 3 and 3 minus y. Not quite the same. Let's see if we could make them the same by doing some manipulation. 3 minus y. Could that be the same as negative 1 times y minus 3? I'm going to put a question mark there. How could we check that? Well, if I distribute that, I would get negative y plus 3. Commutative property of addition says I can turn that around and write that as 3 minus y. So that means, yes, these are the same. I could replace 3 minus y with negative 1 times y minus 3. That might be helpful. So let me write this problem again. I have 15x times y minus 3. And now minus 5z times negative 1 times y minus 3. That looks kind of funny. I'm going to go ahead and take this negative and multiply those together and make that positive 5z times y minus 3. I have something the same. So let me go back. Anytime you have the same binomial but it looks backwards to you, see if what we call those are opposites. They are opposites if you multiply by a negative 1 and it changes all the signs, not some of them, but all the signs, do you get back what you would like? Right? So these indeed are opposites, and now I can factor that. So I'm thinking 15 and 5 are both divisible by 5, so I'm going to take out a 5. I now see that y minus 3 is in common. So if I divide each of these by 5 and a y minus 3 and reduce, but goes into 15 3 times. So I want to put my parentheses. I have 3x plus, those reduce, reduce, and I have plus z. And again, I look to make sure if I've gotten all the common factors out of those binomials, and I have. So I really want you to think about these opposites and be able to recognize those. In preparation for the next class, you should be able to find the greatest common factor of that expression. And then I'm going to work this second problem, and you're going to tell me why I'm wrong. Right? I'm not going to talk, I'm just going to work. You be the teacher, you tell me what I've done incorrectly.